Hey everyone, today I'm going to show you how to make Voronoi diagrams like this. Suppose you have a slab and a set of columns. Voronoi diagrams will show you how much of the slab each column is carrying by area and consequently by weight. This definition allows you to insert columns, delete them, change the boundary of the slab, and even punch a hole in the slab. If you're interested in how the definition works, stick with me through the video. If you want to download it, it's available in the comments. So let's get into it. Alright, so here's a Rhino file. Here's that interactive Voronoi diagram. Points represent each column, and they all live on the column points layer. We can drop additional points by just dropping them in, and the diagram will update. If we want to update the boundary, which lives on the boundary layer, we'll just grab the corners and move it around. Let's just reset that position. If you wanted to draw your own boundary, you would just come in here and draw one and drop it under the boundary layer. If we want to draw a hole, we can go ahead and draw that under the holes layer, and it's going to cut out that section of the diagram. Currently, only one hole is supported, but we could extend this to support multiple holes. The issue is that we have to build a loop, and you'll see why here in a minute. Okay, so if we get into our grasshopper definition, the first step is to create and define our parameters. We have a slab density, which is where these weight values are coming from. We have a slab thickness, which also contributes to the weight values. We have a floor elevation, which is just graphically what the columns will create themselves to. And then we have a column diameter, which again is just graphical at this moment. And then we have a cantilever, which defines nothing. That's funny. Okay, so we have these four parameters. And then we reference all our geometry through here, through the layers that they live in here. And before we go any further, I do want to point out the plugin dependencies. We have to have Elephant, Human, and Telepathy installed. And I'll go ahead and pop those up on your screen here. So it's those three. Okay, so moving on. First, we create a bounding box for the bound curve, and then we use that box to create our Voronoi diagram. It starts untrimmed because the native Rhino component for Voronoi doesn't support a custom boundary, so we have to clip it or cut it ourselves. These are all the intersections that exist between the boundary and the Voronoi cells. They're organized by branch in what cell got intersected, so we can use that information to trim them later. So what we're going to do is shatter the cells and the boundary at every intersection. I'm going to go ahead and visualize this for you. So let's pick a cell index. I'm going to pick one of 2. So our cell index is 2, and there's this function called tree branch index, and as part of the TT Toolbox plugin. This is optional. This is just for debugging for my purposes or for like communication. So cell 2 corresponds to this cell right here. We're going to go ahead and shatter it, take the midpoints of the shattered sections. So we have one poly line that is in the interior, and we have one along the exterior here. We use this function point and curve to test whether that point is on the boundary curve, if it's outside or if it's inside. We use that information to only select the interior section of the cells, and this is the interior section of that cell. I'm going to pick another index because this one isn't necessarily being trimmed. Let's call it 1. Yeah, okay, so cell 1 is being trimmed. So we have this one in here and this one out here, and we're culling this cell section out of here, and we're only left with the interior section. We're going to do the same thing for the boundaries. So we shatter the boundary and cull only the edge corresponding to this cell. Okay, so once we have that all figured out, we recombine here, and we have cells with no hole. We do a really similar operation here, which you can study yourself. It's another shatter and point test. We merge and combine. If we move back here, we combine the oversized cells with the trimmed cells, and it takes a trimmed cell if it can. If the length of the trimmed cells is 0, then it's going to take the oversized cells. Oversized only because they haven't been trimmed. So these interior cells are going to be oversized. Okay, so after we do the combination, we do some loading calculations, which is just taking the volume of the slab, multiplying it by the density, and then getting the cell ratio, which is just the area ratio of each cell compared to the total slab volume, and then multiplying that by the total weight to get each column weight respectively. After that, we use a preview function to just display the weight and the area ratio. So that's pretty much how this script works. If you guys have any questions, let me know. I'm always happy to answer them through DM on YouTube or on LinkedIn. All right, well, have fun with it. Let me know what you think. I'll see you next time.